So in this session, we are going to discuss about the routing concept. What is the routing? Like when data is traveling from one router to another router and another to another router. So multiple routers are there. So how the data will transfer from one system to another system or one network from another network? And all who will define these are the routers R1, R2, R3 and R4. These router will define from where to data will go, what the route will be used by the router. So we will discuss about in detail. So for the example here, like this is the one router. Okay, this is the one router. So this router have a routing table inside it. So what is the routing table? As its name is a table. Table means just a table which having the information. Having the information of the network and the next hop. So routing table is just a storage of the data on IP host, internet protocol host. Host means any single computer or it may be the router used to determine the interface over which the forward a packet. For the example, you have the two interface in your system. One interface is a wired interface which having the IP address 10.1.1.1. Another is 192.168.1.1. Okay, so there is a two interface. This is the wireless interface and this is the wired interface, and you have an application like you are running the ping command and want to connect 10.1.1.10. So can you tell me on which interface the data will be transferred? Of course, wired interface. This data will not go out from the wireless interface. So because inside your computer also the routing table exists. Inside Windows or inside Linux, there is a routing table which will define from which interface will be used to forward the packet. Because every entry must be exist inside the routing table which will represents the available routes to the destination network or the host. Okay, so what the information exists inside the routing table? Like first information is protocol, then destination, interface and gateway. So you run this command show IP route, so it will display some information. Okay, so first information, it will be display of the route protocol. Which protocol used means in a routing the static routing or the dynamic routing is there. If the dynamic routing is there, then which protocol is used? Protocol means RIP protocol, OSPF protocol or the EIGRP, EGP, or which type of the protocol used. Means what is the source of the route? Source of the route. It is static or it is dynamic, and if the dynamic, so which protocol is there? The second information is a destination. Destination means from one system to another, like this router to another router. This have the information inside the routing table. Like if anyone want to go on this particular route, for the example, this route having the IP address 11.1.1.1. So any packet come to this router which having the network ID 11.0.0.0/8. So it will be forwarded to the next hop or the destination. What will be the destination? So this destination will identify with the network address or the prefix. Prefix means long listed subnet mask 255.255.255.0. So while looking of the prefix, or the subnet mask, it will easily identify to the network. Interface, outgoing interface, on the which interface it will be outgoing, and the gateway or the next hop address means who is the next hop. For the example, when I run the IP root command here, so you can see this is directly connected, but adapter is a loopback. Loopback adapter means just a loopback, only the loopback. But 10.1.0, these are the two interface are connected directly. Like the interface ETH0 and ETH1 is connected directly, and directly means like ETH1 and ETH0, there is a two interfaces which are connected directly. But yes, there is a also one route exists for the 10.1.1.0, which is actually via this network. So you will learn more about it in coming sessions. So gateway or the default gateway we have discussed already. So here is a gateway means the next hop from here to here, which the next hop IP address. Hop IP address means the router which have the IP address, it will be considered the next hop IP address. And also if there is the next router is connected, so this IP address will be the next hop for this router. Okay. Similar for the example, here is one router having the R1, another router is R2, another router is R3, another router is R4. So R4 is our next hop for the R3 in this flow. But in this flow, for the R3, the next hop will be R2. Similar in this condition, for the R2, the next hop count is R1. And in this condition, for the R1, the R2 will be the next hop. I hope it is clear, the next hop, interface, destination and protocol. This information actually exists in a router table. So there is two types of the route. One is a static route, another is a default route. As its name is a static always given or provided the information by the administrator. Like you are an administrator and you are going to create a static route, so you can just use it static route, otherwise default route. For the example, maybe there is a for here, like there is some static and there is some default route also. So this is an example of the routing table. Routing table means this is the router A, router B and router C. There is three routers. Router A have this routing table, B have this routing table and C have this routing table. Here in the G0 and G1, Z0 this interface and G1 is this interface, means this network. Now you can see this is not showing only the IP address. This is routing table have the information of the network, only the network. So 10.0.1.0, 10.0.0.1, for this network, what will be the subnet mask? 255.255.255.0. So whatever the packet will come on this router which having this subnet mask or having this network, it will be forwarded to this interface. If any packet which having this network address, it will be forwarded by the G1. But what if any router or any packet is coming with having this network 10.0.4? So what will do? Actually, yes, there is a entry of this interface. means G1. It will be forwarded by the G1, then it will reach on this interface. It will forward to this interface because it have the entry of the 10-4 interface, static entry it is. So static entry means when you are defining the route to the router, it is called static entry. So directly connected, which are the interface is directly connected. Path of the remote networks means the part of the remote networks or you are sending the packet to particular IP address. So it is a path. Host, the route, and the default route. So what is the default route here? Default route means if any packet is coming on this interface, for the example again for the default route here, like there is a only one interface, there is a entry 10.1.0, 10.0.2, 3 and 4. But what happened if any packet is coming 192.168.1.0 for this network? So what this router will do? Because this network entry does not exist inside the routing table. So what the router will do? Router will just discard the packet. Just discard a packet. So for protecting from this discarding mechanism, there is a default route is configured. Default route means if any route information don't have or does not have inside the routing table, so this route will be forwarded on the port on the particular interface G1 or the next hop IP address. So default route like 0.0.0.0. So what does it means? Any packet, any IP address, any network address, any subnet mask will forward by the G1. If the default route does not exist, so it will only check for the static route, only static route, then it will be forward. Got it? So these are the static route and the default route. Static route where you are adding the manually route, it is called static route. Directly connected, I have told you already, which is our directly connected or the active interface. So here is the packet forwarding. How to packet forwarding happened? When it is received a packet on the router 1, it will check the routing table and decided where to send the packet, and where to send the packet will consider their counting of the hop. For the example, when the packet is starting from here 1 2 3 4 5 6 7 8 9, what all these are the hop. If the packet is going here 1 2 3 4 then 5 then 6 3 4 5 then 6, so what happened? It will take a long route. So always used a small route. Always use a small route. For the example, if you want to travel from one location to another location by the car, so what you will do? You will use a short path. Will you use the long? Of course no, you will use the short. So there is a hop count is just a calculation or the metric, and then put it the time to live means how much time it will be live. Live means 64 millisecond or the second, 128 second, it's depend. Then there is a one other type of the encapsulation happened. So encapsulation we have discussed already, adding the headers, it is called encapsulation. So which type of the header can be added? Like IP header, MAC header, okay, in a frame the MAC header has been added. So yes, encapsulation for the interface data is a link protocol, means link layer protocol, or you can see the MAC address is considered. Like when is packet is traveling from here to here only, so it will be just encapsulate, means removing the MAC address coming from this location and then add the new MAC and then forward to this interface. Once reached on this interface, again the same process happened. So this is the same process happened on every router, encapsulation and decapsulation for forwarding the packet. So there is another type of the process happened on the router. This process is called the fragmentation. Fragmentation is just dividing packet into the multiple small parts, means dividing the packet is process called the fragmentation. Like packet creating in small parts. For the example, we have learned about the zombie packet. So zombie packet is used like 4096 the size, but the normal packet have the size is 1500 bytes. So what it will do, it will break the packets into the multiple size, small packets or small parts. This parts called fragmentation. Okay, one more term here, the segmentation we have discussed previously. Segmentation happened on the layer number 4. Segmentation means dividing data into small parts called segmentation. When dividing the packet into a small part called fragmentation. So don't be confused between the segmentation and the fragmentation. So here is the fragmentation happened. So it is happened or it is used for the protecting, like packet might be lost or deliver out of the sequence or the duplicate or the delayed. So for protecting all these things, the fragmentation is required. And also it is unreliable connectionless delivery mechanism to sending the packets from one location to another location. Here the other fragmentation having some information inside it like ID, because if packet has a single and package is divided into the 4 parts, so it is necessary every fragmentation must be identified. So it will be like 1 1 1 2 1 3 or the 1 4, like this type of the ID it will have, so it will identify easily. So by using the ID flags, the fragmentation actually record the sequence and means fragmentation sequence is required. So ID is used for maintaining the sequence. Fragmentation must be fit on the layer 2, depend on the frame maximum transmit unit. The maximum transmit unit is 1500 bytes in a normal condition. And also the path discovery of the MTU. MTU is maximum transmit unit. Okay, so we have discussed about the routing table, path selection, static and default route, routing table example, packet forwarding and the fragmentation.